Ah, the smell of brand new electronics from a brand new computer build. It only lasts maybe 2 or 3 weeks, and after that it goes away. But the speed definitely doesn't, unless you're like my daughters who download a lot of malware, and then your computer can definitely slow down. Hey everybody, it's Dave Dugdale, learningvideo.com. JJ from Asus came out 3 years ago and built me a beast of a computer. In fact, I called it the beast. It was an X299 8-core system. Well, just a few days ago, JJ finished up this build, and this is based off the X299 system and is a 16-core part. This is going to be a pretty long video. It's going to be about 2 hours long. So if you want to skip ahead to a certain section, I'll put content markers down below. So for instance, if you want to skip ahead just to the benchmarks, when we test DaVinci Resolve, Premiere Pro with this machine, definitely go check that part out. So this is going to be basically in 3 kind of sections where JJ builds the machine, and then JJ sets the computer up in terms of the BIOS, the Windows, and all the settings. And then the last part is basically the benchmarks and the testing. Now when JJ contacted me and said, hey, you want to do another computer build like last time? I was like, heck yeah, count me in. For full disclosure, I get to keep this computer, and that's one of the reasons I said, hell yeah, let's do this. But the other part is really when JJ comes, he comes for usually 2 days, work about 10 hours a day. And I know computer builds don't normally take that long, but when you're filming and I'm asking him tons of questions, I'm constantly stopping him, and he's answering all the questions as we go along. There's basically, I'm filming for probably a total of maybe 16 hours. I condensed that down to 2. So this is a pretty comprehensive build. However, I'm not going to show you every single interconnection that goes on. But basically, if you're trying to build something like this, what I'm trying to ask the questions are, you know, what are the common pitfalls most people do and get in trouble in terms of the software, the BIOS, or maybe not setting up the XMP correctly, stuff like that. All right, before I get a bunch of comments down below, it's like, David, total sellout for keeping the computer. Think about it this way. I have like 500 YouTube videos on both my YouTube channels, and the vast majority of them are about camera gear. I think there's only 3 about computer hardware, like a computer build like this. This is not really in my wheelhouse, so I don't think there's a real conflict of interest there. So full disclosure, I just want to be up in front and honest about that. All right, before JJ tells you what's inside the case, a few quick corrections. What's actually installed is the 16-core, 32-thread 7960X. What was supposed to be installed was this one, the 10-core 7900X. There was just a miscommunication in shipment, and that one actually got sent to my house. I don't know if I'm going to be able to keep that one, but what I'll try to do before I send one of these back is do a comparison between the 10-core and the 16-core. And I don't know what the pricing is on these yet because they haven't actually been released. The other items I want to talk about is the graphics card. We moved the GTX 1080 Ti from my old computer into the new one, so he didn't supply that. And he didn't mention the case, which is the Fractal Design Define R5. So he'll talk about that more later coming up. What do you go to next?
Next is, of course, going to be the motherboard. So in your build, we use the X99 Deluxe from that generation. So here we're tapping the same series. It's the Prime series, really focused as really kind of a board for anybody, content creators, enthusiasts. It doesn't really matter. It's going to have every single kind of spec you could ask for. USB 3.1. It's got, you know, gigabit LAN, onboard Wi-Fi, M.2. You know, there's not really going to be anything that's on this board that you would be missing. You know, it's all inside the box. It's ready and set to go. So the memory, we're going with Corsairs right here. This is their Dominator Platinum. It's 64 gigabytes. Your previous build was 64 gigs, but 2133. So here we're just stepping it up to 3200 in terms of the frequency. So quite a bit higher in frequency. More bandwidth means more performance. As we move from there, we've got, of course, the cooler. Cooler is a critical part for the build. We've got a fairly high TDP here for the CPU, and definitely if you overclock it, even overclock it efficiently, you're going to deal with even more heat that you have to manage. So here, your previous generation was a 240 millimeter base setup. Yep. So here we stepped up even to a higher performing 360. This just means that we have more airflow, more ability to displace, but also able to keep the system quiet. So it's optimally tuned for that. It's Fractal Design's Celsius S6 model, and it does even allow for expansion, but for our configuration, there's not really any need to add in the GPU in terms of being cooled, so we won't be using that, but otherwise, good choice here in terms of that. Power supply, we've got Seasonics Prime Series. This is their flagship titanium line, 1000 watt. So with this type of system, you are going to be pulling quite a bit of power, especially when you go under full load, when you're using the CPU, the GPU, all these components. So we want to make sure that we have enough power. We want the topology and the design to be very reliable, extremely efficient. So that titanium rating does that. And they have an outstanding design in terms of their internal components. A very good build quality. Make sure you got long-term reliability in mind. And it's also fully modular. Not really a requirement for the build, but it will make things a little bit easier for me in terms of just routing the cables. Supplementing the Fractal designs is going to be some dynamic X2 GP14 fans. These are just great quality fans. They're 140 millimeter, more airflow, quiet operation, good bearing design for long-term reliability. And then supplementing the storage configuration, just DaVinci Resolve, you really need good GPU, CPU, memory, and storage. So we've got Samsung's flagship. This is their 960 Pro M.2. So this is PCI Express and NVMe. That not necessarily always exists in tandem. So it's a by 4 base drive. This one specifically is a 1 terabyte model. We'll be adding some additional M.2 in there. Very high performance. The one consideration point here is that with really fast drives like this, they do have somewhat thermal considerations. And so another reason why the Deluxe is a really great choice is we have optimized M.2 layout, which we'll get into when we build. Okay. Helps to make sure that we get good thermal reliability. And then we've got 2 terabyte Samsung 850 Pro, which will supplement that primary fastest storage, which is on the PCI Express side.
Yeah, so I mean, it's a fairly straightforward process. One of the tricky parts is, of course, is as you're actually removing the cantilever here and bringing up the actual retention plate is that people tend to not, I think, keep enough dexterity in their actually fingers here when they're dropping this in. So you just want to make sure your hands are dry. Sometimes it can allow you to kind of just have a slight angular slip, and that's enough to sometimes then have this CPU going slightly at an angle and then actually cause maybe some depression or some damage to the pins. And that's definitely what you don't want to have happen. Beyond that, everything else is pretty straightforward. I mean, once we've gone ahead and opened up the plating, we're just going to push that retention plate back down, bring the actual bars back in, and we have the CPU locked in place. At that point, you're pretty much good to go.
Now, in terms of thermal paste, when we get to the cooler, did it come with thermal paste?
Yeah, so that's one of the great things is with a thermal cooler like this, traditionally I'd say tower heat sinks. So like if you were to do something like a Noctua tower, that's going to be where you have to manually apply the thermal compound. But with generally almost all closed loop water cooling solutions like this one, this Celsius S36, it's already pre-applied. And there's the discussion, should I change it? Actually, in most situations, the thermal performance that this unit has been rated for was with that included thermal compound. You changing it, you could actually, unless you 100% know that you're getting better thermal compound, it could be worse. This board's a little bit different in that traditionally most motherboards, when you mount the actual M.2 SSDs, you'd find the M.2 slot here. It would generally be directly underneath the graphics card slot. But we actually are looking for thermal isolation. The reason why that's important is because we want to be able to ensure the best thermal performance for the M.2 SSDs. So the M.2 has been intelligently placed. We have one vertically right here, which will be directly next to the DRAM. That one will actually use a special mounting system so that we can mount that on there and we'll have it vertically set up. And then there's also one directly underneath this metal heatsink, which will then be able to ensure that you have the good thermal performance. So we're going to go ahead and first get the standoffs for the vertically mounted M.2 installed. And this is where ideally some people wonder is that you do want to have a generally precision tip screwdriver. It's going to make your life easier. You won't be able to use generally one screwdriver as in the past. Usually one screwdriver would be all you would need for one build.
So how many M.2 slots are on the board?
This one has 2. There's one vertical here, and then there's another one directly underneath this metal heatsink. And then you could, of course, optionally install more via actually an add-in card. So like we make a Hyper M.2 add-in card, so that goes into a PCI Express slot if you want to have more M.2. And this board does also, another reason why when we asked earlier about picking X299, this board does support Intel VROC technology. What that will mean is that we will come with a Hyper M.2 expansion card, which can actually support 4 M.2 modules on one single add-in card, and they interface directly with the CPU. And so that does require a special essentially key module and support from the chipset, but that would work just from a PCI Express add-in card. You put your M.2 drives onto that add-in card and you'd be good to go. So a lot of different choices when it comes to M.2 on this board. Open this one up. You will need to remove the thermal interface tape that's underneath the heatsink so that when you actually mount your M.2 SSD that interface material makes direct contact with the M.2 drive. And I don't have one here, but if you use one, it's great to always have a magnetic screw tray. Makes things easy when you got these little small screws. They don't go rolling off, you don't lose them. All right, there we go. So you can see right there, you got your thermal interface pad material. This you want to be careful. You don't want to try to touch it with your finger because just, you'll get stuff all over it. We will need to mount one M.2 standoff right here to 2280. So we're going to put that on there. You want to make sure to mount that. If you don't have that mounted, the M.2 SSD will not sit correctly in place. All right, we're going to get this M.2 installed here. It's keyed in, just here until it clicks. Move down, and then take your M.2 screw.
So talk about like the M.2. When I was thinking about ordering one at one point, it looked very confusing in terms of there's lots of different styles and stuff like that. How do you know what to buy for that motherboard? How do you go about figuring out which one's the best for that board in terms, because there's so many different slot sizes?
There is, well, generally the M.2 itself is keyed either with an M or M+B. So generally what this comes down to being is that there's 3 M.2 drives. You have SATA, you have PCI Express, and then you have PCI Express with NVMe. Pretty much all current generation chipsets will all support PCI Express and PCI Express NVMe, but you want to check to see if the motherboard will support SATA. SATA-based M.2 drives are essentially going to be the same exact performance as something like a traditional 2.5-inch SSD. So in that regard, you're not really getting any performance benefit. The only thing that you're gaining is essentially the simplicity of not having to have a SATA power cable and data cable. So if you like that convenience of just dropping it into a board, you can definitely go that route. But keep in mind, there is still that thermal concern consideration that
yeah.
On a more basic board, even still with a SATA, ideally, you don't want to try to have this be in a zone where a lot of times if it's underneath this graphics card, you're getting a lot of heat pulling because that graphics card is right here. And if that drive is right there, all that heat is pulling directly on that component. And so I would still try to strive for getting a board that has either thermally isolated M.2 or, because in most situations, the traditional SATA-based SSDs, like if you take a look at the Evo series, the 850 Evo M.2 and then the 850 Evo SATA-based SSD, they're essentially price parity. So because every chassis is going to give you traditional SATA support anyways, I'd probably just go with the 2.5-inch drive myself. And then I would only reserve to go with M.2 when I'm going for a higher level of performance, whether it's going to be PCI Express or PCI Express NVMe. So here we're just essentially going to place back on the heatsink. So if you notice, this is an aesthetic aspect because of course it's part of the style, but you can see that when I pull that off, that thermal interface material is making direct contact here with the M.2. And that's important because this can really reduce the overall operating temperatures by about 15 degrees, or sometimes even not a little bit more. And that just helps to ensure that long-term this drive is operating at its peak level of performance, because if not, the performance can degrade fairly substantially, especially with heavy writing. So when you talk about professional content creation workflows, working with raw file sets, really big files being consistently written to the drive, over an extended period of time, drive's going to heat up. And so that's where having a scenario like this, having a solution like this is going to be advantageous. So I finished installing right here the secondary M.2. So we've got one M.2 right here. This is a 960 Pro as well, 512 gigabyte, and then we have another 960 Pro 1 terabyte. So we've got two. Now, one of the interesting things that the X299 chipset does support, and I know a lot of people have questions about, is rated-based configurations. Something right now that X399, let's say on the AMD side, doesn't currently support is NVMe rated-based configurations. They will eventually enable support for this, but as of right now, it's not yet available. So this is another kind of current benefit on the Intel chipset, and their RAID implementation is very proven and consistent. Now, I don't always recommend rated configurations because it is more points of failure. Having single drives, I think, are easier in terms of being able to manage their backup as well as how you use them in, I'd say, assignment purposes, whether you're talking about scratch, primary, secondary storage, whatever purposes they might be. When you go into rated configurations, you run into the possibility of, like I said, concerns on points of failure, as well as then also optimization on how you can run certain types of performance monitoring options as well as recovery options for the SSDs. So in this scenario, we're going with two independent kind of setups, but the board would support that if you did want to go with a rated setup. All right, so we're next gonna go ahead and now move into the memory. So with DDR4, it's a pretty straightforward, especially with the Asus board that we have here. It's an open-ended, it's our QDIMM design, which means there's only a single memory latch. So when we essentially push this in and we hear the depression click, we only need to watch it on one end and we're good to go in terms of the memory being seated. Now, if you don't go with a 64 gigabyte kit, that's 8 DIMMs, you might only do essentially 4 DIMMs. You do want to look at the silk screening on the motherboard because it will indicate to you which memory channels you're going to want to use. And this is very important because if you don't use the correct memory channels, the board may not actually post. It might not actually power on correctly. So you do want to follow that. You'll see that on the board there's essentially either gray or black slots. For us, it won't matter because we're actually going to populate all 8 slots in total. Now, one other important consideration, though, that is, I'd say, the most common point of issues within high-end systems like X99 when you have quad-channel memory is people mixing memory kit configurations. So you might find a great deal like on something like B&H, and they're like, oh, I see 32 gigabytes, right? And this 32 gigabytes kit, they put it in, and then later they see another deal at another time for another 32 gigs. They're like, I want 64 gigs. So they buy essentially 2 32 gigabyte kits. Now, in theory, that should be all compatible, and it is from the perspective that it's all DDR4, it will all physically install, but there is a couple of concerns that come into play. One is something called memory timings. So when you talk about memory modules, there are usually 3 things to keep in mind. One is going to be the frequency of the memory. This is 3200 in terms of the speed. The other will be the actual timings. This is referred to as CAS. So this is a CAS 16 module. Generally, the lower the better. And then there's also the voltage for the memory module. So they operate a certain voltage. So this is 1.35 volts. Well, the thing that happens is you increase not only the memory frequency, but also the density, is that the timings and the voltage may have to be adjusted for that combination. So if I give you an example, a 32 gigabyte might have timings that run at CAS, let's say 17, and need 1.4 volts as an example. And that's not the case for this kit, but let's just say it as an example. But if I buy another kit, that kit could have a different CAS standard. It could be CAS 16 and 1.35 volts. And when you mix them all together, they may not optimally work together in terms of performing correctly. So that means that you might actually have to manually tune these parameters yourself. So you might plug everything in and then wonder why isn't everything kind of just working at those speeds correctly. So what this ultimately really boils down to is that we try to really recommend that while it is a little bit more expensive, you really try to buy the target memory configuration initially. Or you have to be prepared for the fact that you may have to manually tune your memory, especially if it's a mixed memory kit. The other challenge is also frequency. While this kit is 3200 and the motherboard actually supports a much higher frequency, the CPU has something that's called a memory controller built into it, and you need to be able to, you don't know actually what the maximum speed that memory controller can support in there. It's a little bit of a variable. So this is a really confusing topic for many people. There are 2 speeds that when you have a memory chip. One is called SPD. This is the serial presence detect. It's the baseline guaranteed frequency that this memory will run at. And then there is the XMP memory speed. The XMP memory speed is technically an overclocked memory frequency. It is not a stock frequency. You will need to manually set the board to run at the XMP memory speed. The higher that also you go, the actual lower the probability the CPU and motherboard may be able to run that memory combination. It's just the reality that you're pushing really high frequencies. So here we tried to pick a balance of a memory frequency that was high, but that I know that pretty much about like 90% of the Intel CPUs will be able to run at that higher frequency. But take, for instance, if I bought like a 64 gigabyte kit that was like 3866 or like 4000, it might be a significantly smaller percentage of those CPUs that could actually operate that. Even though you paid for 4000 memory, the motherboard says that it can run 4000 memory. The memory controller, because it's an overclock frequency, it has no guarantee that it can actually run out that speed.
Yeah, in terms of memory, I noticed that once I got that 64 gig from the last time you were here, we built the other system, I didn't see so much of the need in Premiere Pro, but when you went to After Effects, you give it 64, it'll take every little bit of it.
Yeah, you find generally for a lot of applications that do a lot of real-time kind of effect adjustment, they will generally move things usually actively into memory because it's one of the fastest points within the system, even faster than your SSDs. And so they tend to benefit very much from not only the bandwidth, but from an increased density in terms of the actual memory. And so you can see here, when I'm putting it in, I'm making sure to align the notching pattern, and I'm just depressing down on both sides and making sure that that essentially clicks in place. Now these modules also have heat sinks in there. Sometimes people wonder, your original DIMMs did not have heat sinks because they were running at a fairly conservative frequency. But when you do get to higher memory frequencies, it is sometimes actually important to consider some of the thermal load. In most general user considerations, memory is never going to really heat that much up. It's not going to produce a lot of heat. But each memory module can start to produce a couple of watts. And when you put this memory modules together, it actually can be a decent amount of little heat to dissipate. And so this is where airflow considerations can come into play, whether one, you want to have a revised airflow strategy of bringing intake airflow instead of exhausting it out. You want to bring it down and directly across the DIMMs and across this portion of the motherboard. Or you actually have an option that these Corsair kits actually come included with their own dedicated actually cooling solution. So these can actually be mounted directly on top there. And it depends really on your usage scenario. It may not be a requirement, but there's never any harm if you actually use this. This will only help to ensure the actual best stability. So this is something you kind of have to look at your workflow. If you're using your memory heavily and you're seeing you're always like in that 32, 40, 50 gigabytes of active memory space and it's there for an extended period of time, it actually may be beneficial for you to use the active cooling solution to ensure the best stability, because what you might run into over time is that you might find it's initially stable, works for no problems, but then after a few hours, because there's a lot of consistent heat, then you actually can lead to instability later at that time. So this is really driven by your workflow, and that's something that a lot of people ever really talk about in terms of active cooling, but it is something to consider once you get into higher frequencies. Frequencies, I would say, is probably once you start to get to about around this 3200 speed and graders, and especially when you're talking about fully populated configurations.
The different boards that you guys make, because this one, what is this got to be, like a $400 board?
Deluxe, I think we just dropped it, but yeah, it's something in that yeah, three.
Because I know you have like a deluxe and you've got different.
Specifically for this series, we have the A, and then we have the deluxe. And really, from a quality and stability and even core functionality standpoint, the boards are almost identical. If you talk about the class of fan controls, even our M.2 isolation design, support for great stability when you talk about overclocking the memory or the CPU, the power delivery design, they're all going to be consistent. The main differential really comes into a couple of key areas. One, connectivity and expansion. Take for instance this board here, it gives you more extensive I/O. This has integrated 802.11ac dual band Wi-Fi and even a newest 802.11ad. This is actually a 60 gigahertz spectrum. So this is actually a truly gigabit class wireless. You can actually have faster than gigabit based Ethernet based speed through an 802.11ad based connection. The AC connection is very fast, very low latency. On average, it's probably about 3 to 4 times faster than 10100 Ethernet. But you then also, of course, have dual Intel gigabit NICs on here. This is great maybe if you're running like a high performance, maybe local LAN-based storage setup. You maybe have like a Synology, a QNAP, an Asus store, or something like that. You might have that locally connected, and then you might still have a dedicated outlined internet connection. You have a lot of different functions here. So this is stuff where this is not really required for every single type of user, right? Some users are fine with a single NIC, no need for Wi-Fi, right? Maybe 2 less USB 3.1 ports, right? In that type of scenario, that's where you're really going to see the main difference between a -A, so our more entry-level X299 SKU, and then a higher end version with this one being the deluxe board. So, you know, you can also look at it things like here where you've got like U.2, you got SATA, then you have, you know, your right angle front USB 3.1. This board also comes actually included in the box with Thunderbolt 3 add-in card itself, which is actually a fairly expensive add-in card to give you even more USB 3.1 and Thunderbolt 3. That doesn't come included with the -A version. but it does support it. So you could buy it later if you wanted it to, right? So we haven't tried to really exclude any one key area. So again, if you're talking about just stability, reliability, the core experience of performance, they will be parity. It just really comes down to, I think, the total kind of connected experiences available, even for things like fans. Here, we're gonna have a decent amount of fans and there's more than enough fan headers, but this board also comes with our secondary fan extension card, which is inside the box, which even allows us to connect even more fans. And that can improve cable routing because I don't have to maybe run as many wires directly to the motherboard. So those are all things you kind of can look at the website, kind of compare and see, do I need maybe all those things? Very similar to kind of cameras, you know, sometimes maybe I don't need the headphone jack. I'd love the headphone jack, but maybe I'm going to do an outboard recorder or something along those lines, you know, or maybe you don't need dual memory cards, right? Because maybe you're not a super class professional, so you're fine with just one memory card. So next up, we're going to go ahead and drop in the motherboard into the chassis. So this right here is a Fractal Defines R5. So this is, I'd say, very much centered towards a lot of expansion, flexibility, good cooling, and acoustics, as it's got a lot of internal dampening that's present there. So you can minimize things like vibration, especially if you're using a lot of hard drives, and also just to be able to provide a lot of flexibility. And the reason why flexibility is important is, if take for instance, we look at the cooling solution that we're using, that Fractal Designs S36, the Celsius S36, it's 360 radiator. So the challenge that you have here is that this is generally only opened up for 240 millimeter. But because of the way they designed this, I can actually remove the 5 1/4 bay. And based on my recollection, I don't believe you use an optical drive at all.
I do in my other case, but I haven't used it in like 6 months to a year, so okay. I don't need it. If there's room for it, that's fine. But you know, it's one of those things can't remember the last time I used it.
Right, right. It is always nice to have it. And I actually advocate sometimes for an optical drive. Blu-ray can actually be advantageous for things like archival purposes, to archive or even put out your actually content and be able to share it easily with people. But for that purpose, if you still needed that, of course, you could also consider a USB external. That's an option, and you know, we actually do make some. So if you're interested, you guys can check those options out. But for physically installing this, we will need to remove this top cage right here. So this 5 1/4 cage will get removed so that we can mount the 360-degree cooler in there. This will still leave the drive bays open, but these drive bays can be removed if we want to be able to also improve the intake airflow. This is all really conditionally based on how you set up your system. Do you want more directed airflow that's coming in from the intake? Do you going to run a 360, or you're only going to do a 240? So those are kind of things to keep in mind. So I will remove this so that I can mount the CPU cooler in place. I'm going to first just quickly mount the IO shield. So I'm going to pop this right here into the back. From then there, I will remove this portion of the tray. And actually, I find most likely to make it easiest, I will pre-mount the CPU cooler. And then from there, I will then install the motherboard. And here, it's always easiest if you kind of angle it in and then just depress it each corner until you... And then you just want to go back, follow through, and make sure that all sides are evenly extruded.
So with this 10-core part, is it going to run a lot hotter than the 8-core part that I currently have?
There is going to be, actually the TDPs, or quote unquote, are fairly similar, but yes, it's a 140 watt part, but when you talk about definitely being able to increase the performance through overclocking, we can easily breach 200 watts. So we need something that can really comfortably be able to handle that. But to Intel's credit, you know, their adaptive voltage policies that allow for performance tuning really can allow for a far more efficient level of how temperature is dealt with and how voltage and heat is considered for this type of platform. So a lot of benefits there, but overall, I mean, definitely this is a serious platform in terms of the airflow that you need to have to be able to ensure that everything is running reliably cool and also quiet.
What about the Threadripper part in terms of its TDP? How does that compare? Does that need even more cooling?
It is. I'd say it can't even run into just as extreme, and even in some scenarios actually even more. The 1950X right now in our own lab, we've had scenarios where, you know, that CPU is pulling 350 watts plus. So that's quite a bit of power. And even in the way that we have the motherboard for the power delivery design, these are important things because not every board that you'll find, if we take a quick shot here, have actually dual power connection. So historically, this has been seen as kind of a supplemental power design. Really, I feel for this high-end platform, it's a requirement because the 8-pin interface is only designed for a certain level of maximum current draw. So if actually you begin to overclock, you're actually literally exceeding the current draw that this interface header is designed for. So we, on all of our X299, have put essentially an auxiliary to allow for essentially more headroom. That means that we're putting less quote-unquote pressure, right, in terms of the current draw on just one interface. And even if we get really tight, you might be able to tell there's a very interesting design that we have on this header interface, and this is even for our AMD-based solution. But if you take a look here at the 24-pin, you will see that the internal wiring gauge is quite thin. It's very small. You might barely see the actual pins, quote-unquote, internally. But if we then shift over to here, you can see how these are very easy to see.
They're bigger. Yeah.
And these are actually a significantly thicker gauge, and that it comes into resistance. Essentially, we have much better performance in terms of the current draw. So this is something actually we developed on our server series of motherboards, our workstation series, because they were designed for extensive high-level sustained current draw. So you know, it's kind of that benefit of getting a better class board make sure that you get a better experience over time.
Because I kept hearing from, like, you know, all the tech channels like Linus Tech Tips and Paul and stuff like that, that the AMD has, I forgot, 40 piece lanes or something like that, where this has 16 or something like that?
No, so the current flagship Intel part, the highest ends have 44 PCI Express lanes. 44. Okay. Right? That's already more than the basic mainstream chipset, which is 16 lanes. Okay. And then on AMD's part, the highest end part, only Ryzen Threadripper X399, not Ryzen on X370, those support 60 lanes, and then they have 4 lanes through a secondary option, which is for the chipset. So 60 lanes versus 44. But both is an extremely high number of PCI Express lanes that literally would let you run multiple GPU configurations, multiple M.2 based SSDs, and still support all the secondary external controllers.
In terms of content creation, where do you feel having enough is enough in terms of those lanes?
For me, I think realistically, I'm okay with even 28 to 30. Like if I had 28, which is a possibility on some of the lower end parts, I feel that that is a justifiable option. I'd say the only content creators that could justify needing the highest echelon, so 44 or even potentially that higher amount that is available on Threadripper, would come from somebody that might be doing specialized heavy multi-GPU workflows in applications maybe like Octane. Octane is it's a professional rendering application that almost doesn't use any CPU, and it's all almost exclusively GPU dependent. And it doesn't need SLI or Crossfire, it just looks at each GPU that might be installed. So if I'm running 4 consecutive GPUs and then maybe doing other things, there might be merit to that type of configuration. But that would be really the only type of, I'd say, content creator. For standard, I think videographers, photographers, while Resolve and some other applications can potentially benefit from a secondary GPU, it's in its very early stages of really getting good secondary GPU acceleration. We're starting to get into really good levels of primary GPU acceleration in terms of core count, the amount of memory that's utilized on the graphics cards and things along those lines. So I think that you want enough lanes to make sure that you can have as much devices as you want in terms of storage, GPU, and all the add-on controllers. But in terms of secondary expansion, I don't think it's as critical. Yeah, no, I think, you know, part of the bigger convention from, at least from a lot of the media that have covered the topic, is because they're kind of trying to drive a narrative of they want to maximize the value arc, right? That, like, you know, hey, and it is great, you know, that you can buy the 1900X and get 60 lanes, right? But I think that the person that benefits from that has to understand exactly where they're going to use those 60 lanes, right?
So what chews up the lanes? You got obviously the GPU, you got the SS or the MVMe or M.2 MVMe. Right. What else chews up the lanes?
That would be it.
Those are the only
just graphics cards, and then just M.2 SSDs.
And so how much? So you can put 2 M.2s on there. How many lanes does that chew?
That would be 4.
And then what does a graphics card, 16?
16 or 8, but actually in reality the 8 is
So
pretty much the same
two
performance.
graphics cards at 32 plus 8, that's 40 lanes.
Yep.
Okay.
And you still have 44, so you still even have...
Yeah, so that, I think that's
Plus
plenty.
you still also have lanes that are provided from the chipset that is providing bandwidth to the add-in controllers, like things like your Ethernet or USB 3.1 or kind of other items like that. Okay. So yeah, you still got enough to be able to get done what you need to get done. So pretty much what we want to focus on is that it's about trying to focus the airflow to key components. So if we bring back kind of our motherboard back into the shot here, we've got a lot of heat that is really being produced in this top zone area, right? We talked about our DRAM, we talked about our CPU, and then this is the VRM, or the voltage regulation. So this is the heatsink, and then we've got the power componentry here for this portion. So this all is really producing heat. Your graphics card will produce also some additional pooling of heat, and you want to account for that. But one of the interesting situations here is that, of course, with the closed-loop cooling solution, we know that we're going to have more than enough surface area and coverage to really keep that CPU nice and cool. But one of the disadvantages you have with a closed-loop cooling solution like this is that there is no direct general airflow that is created for the surrounding components. And so this is kind of where you want to try to account for that within the build. So you have generally two options. One, intake airflow. So if we imagine airflow coming from this direction in and flowing across, that could be managed. Or you can also adjust the top mounted fans. And historically, most people would probably have their fans exhaust. So here I've got a fan that would be mounted like up here, and hot air rises, so it would go out. That's not necessarily a bad option, but I generally find that in a high-end platform, I recommend to flip that up. You actually change it and you actually draw cool air in from the top, and you have all that airflow correctly come right across all those components. And we have found in our thermal analysis that is more beneficial than exhausting that hot airflow, because the chassis does still have enough pressure and exhaust through the rear fan and through venting, so that if we bring that cool intake airflow, it will still then push out and go outside the system. So we are going to set it up where essentially we are going to bring air flowing down across these components, have a natural exhaust, and then an intake airflow. And one of the nice things that Fractal did actually with this cooler is normally we'd have even more cable routing concerns, but one of the really intelligent things that they did here is that it has an integrated PWM fan splitter cable. So, but hub board actually built on board. So you can actually see here we have 3 headers. So normally you'd essentially have these 3 fans, and you'd have to be able to connect all 3 of these fans normally to the motherboard, right? And our fan design on this board allows for very interesting situations. We could do a splitter cable on one of the CPU headers, or we could use a fan extension card, which gives us 3 temperature inputs or fan header inputs. But here, we have the ability that essentially we can still have the control signal sent from the motherboard, but we can connect all 3 of these fans directly to here, run them all here, so that simplifies the cable routing, but still have the board control that. So it makes this overall experience more streamlined. So yes, a little bit more expensive, but simplifies the whole experience while it also gives us still better cooling. Yeah, here what I'm just gonna do is I'm gonna essentially do a sanity fit to look at the placement for the board, along with then where I'm gonna pre-mount the cooler, because I am still gonna put the cooler in first, but I just wanna make sure that I don't find any little mechanical conflicts. Yeah, so if I did it like that. Yeah, I think I do like it the other way. So now I'm going to go ahead and quickly set up the fans for the actual radiator. You can generally check for this setup. Fractal does a really nice job that there's actually indicator marks that they put on the fans that will let you know the actual intake or outtake airflow. So that can make it useful, because sometimes people wonder, like, I don't know which direction I'm supposed to place the fan. So there you can see that there's an arrow that helps to indicate essentially the directional airflow. And so for my purposes, essentially, remember, we want to have essentially that downward firing airflow. So that's how I'm going to have all my fans laid out, so that when I move those into place, I'm good to go. So we're just going to get those all situated here. Okay, so we've gone ahead and got all the standoffs in. It's pretty easy to count. The motherboard, usually also the tray internally of the chassis usually also will have letters that will indicate the form factor. This is an ATX-based motherboard, so generally you're always going to have 9 standoff points. So we've gone ahead and installed all the standoffs. We've tightened them in there. You do want to try to make sure that they're just a smidge over, I'd say, finger tight. And the reason why is that when you end up going to put the actual screw for the standoff, if it tends to be a little bit loose, when you tend to actually start to apply the torque, you may actually inversely kind of unscrew the standoff. And then you'll end up with kind of a loose mounting. So you do want to try to make sure that it is fairly tight. You don't need to super over torque it, but try to get it a little bit firm in there. So I'm going to quickly actually pre-connect. Oh, sorry. I'm going to pre-connect these leads again. So this is the supplemental EPS CPU power connection, and then we have the primary. And while it's not required for this type of a high-end configuration, I absolutely recommend that you also use the secondary supplemental power. See, okay. Yep, and you can see actually right here, we just want to make sure that essentially the Wi-Fi is correctly extruded through the actual fitting holes and that everything is lining up correctly. If you see that anything spaced is off, you want to make sure to go back and readjust the board until essentially everything is flush mounted. And you also need to be cautious that there's actually a small extruded metal piece here that actually should sit on top of the actual Ethernet adapter and controller port. And you don't actually want it to be inside the port.
So what happens to the SSD if it gets too hot? Does it thermal throttle somehow?
That's correct. It's just like a CPU.
So does it decrease the speed and say, hey, slow down, I'm getting too hot?
Yes, that's exactly what will happen. And the performance degradation can be pretty substantial in some scenarios, 20%, 30%. Some really bad if it's very excessive pulling, you might even get like 40% throttling in terms of the degradation. And it can also be one of those things like it could drive you kind of crazy when you're working, because what might happen is that you can also get irregularities in the performance of the device. So you might not necessarily realize that it's thermal throttling, but you're getting just kind of these weird spikes in your workflow where it's like things aren't kind of going smooth, and you're like, what? I don't get what's going on. Why is it not working as fast as it's supposed to? And that's really just because of the throttle. All right, so next up, we're just going to start with actually mounting the standoffs that are needed for the CPU cooling solution. So there's usually a couple of different sets, always included with the cooler. The fact that this is an X299 platform makes things really easy because the actual socket itself, retention plate, is pretty much all primed. So nothing is required except for literally just getting these standoffs threaded in there. And then we will just directly mount the actual cooler right on top of that, and we don't have to worry about any thermal compound, thermal interface material, because it's already pre-applied.
So if it wasn't applied, I do have some Arctic silver, but in terms of the thickness and how much goo they got on there, is that better than doing it yourself kind of thing with Arctic silver or some other?
This has been really well, one, they've already validated this to meet the actual rated temperature performance of when this unit is seen. So in pretty much every review, if we were to go look for this unit, it's done with the pre-applied thermal compound. So it's allowing you to ensure that you get the same consistent performance. If you apply your own thermal compound, one, you could over-apply, which could actually produce worse thermal results. If it's a compound like Arctic silver, you actually have a concern that because it does actually conduct, you could actually short something. So you have to be cautious in terms that you wouldn't want any to get it like in the socket or any of the surrounding area, anything along those lines. So you do want to be cautious. What I would generally recommend though is that if you do go about applying thermal compound yourself and you get a very high quality thermal compound, use something like a finger cod and just manually spread it evenly across the entirety of the IHS. I find it's the most consistent way to actually just make sure that you get even, consistent distribution.
For those people that might screw up and do something wrong, is it okay to take it back off again and put it back on
yeah,
again?
for sure. So if I just were to pull it off right there, you can actually see already that it's begun to essentially imprint. And what'll generally happen is that once you put this on, you first fire up the system, it'll warm up. And when it warms up, of course, that will begin to create that more complete bond. But you don't really have to worry about, like, all of a sudden, if you didn't aim something correctly, that all of a sudden you need to reapply everything and do it all over again. You're entirely okay.
Cool, because I've kind of done that before. I see you're jiggling it back and forth a little bit.
Yeah, it's just to make sure that, one, I just do that as a sanity check to make sure that the torquing of the screws feels good to me. And then usually I just put the thumb screws in a cross pattern to allow it a little bit consistency, and then I just finish it off on each side. And like always here, you know, the golden rule is to kind of more so go for finger tight. You're not really trying to heavily torque every single thing down here. You're just trying to make sure that there's even distribution of pressure. So next up, we're going to go ahead and just remove here the 5 1/4 bay. This is just so that we can go ahead and mount an additional fan here. Now, one of the really nice things about this Fractal Define R5 is giving us the flexibility that you can move around the hard drive cages in a lot of different configurations so that you can either add more airflow or have less expansion needs in terms of your storage configuration based on what your workflow and what your kind of hard drive configuration is going to be like. So for me, one, I do want to be able to bring a bit more intake airflow for this system. So we can see that by default, they do include one fan. Now, I did remove that with just the 2 thumb screws. There actually are 4 other screws that affix it underneath here. So those would need to be removed. Just keep that in mind. So we can see here we have an open cavity to add in an additional fan. So we're going to add in another 140 millimeter fan. So these are going to both serve as an intake. All right, so we're going to get our Seasonic Prime Titanium power supply. This thing is a beefy power supply.
Does it feel pretty heavy?
It feels pretty heavy. It does feel pretty heavy.
And are they one of those type of manufacturers that sell their
correct. They
to
are
other people, and then other people just put their name on it, kind of thing?
They are a true flagship, and they are actually not only a branded power supply manufacturer, but they are also a kind of an ODM. So they do actually take kind of their reference designs and then work with partner companies that will essentially rebrand their power supplies. They may make slight modifications to it based on the request of that partner. But you know, with the branded Seasonic, really, you're always generally getting really outstanding topology. And then what I mean by the topology is kind of the design of how they've laid out the power componentry, the transformer, all kind of the internal components. They really have consistently set a recognition in terms of high performance.
If you have a power supply, it's 1,000 watts, and you have a power supply, let's say, 500 watts, and let's say, you know, the system could handle the 500 watt power supply, no problem. Does one use more power over the other?
No. So just because it's 1,000 watts doesn't mean that it's going to consume more power. It just means that in totality, right, you have up to that peak level of power that can be pulled from the power supply. So you don't have to worry about from questions like that this is going to inherently consume more. If the total system is only drawing 450 watts, then it's only consuming 450 watts. That's all you have to worry about. Now, there is a difference in terms that going with the higher gauge power supply and these efficiency ratings does affect this overall consideration in terms that the power draw, right, you have to look at it from a percentage. So 450 watts is using almost peak of a 500 watt power supply, and it would be better to use 500 watts of a 750 watt power supply than to use 450 watts of a 500 watt power supply. So that's where you kind of want to try to balance in that you don't want to be using the entirety of that power supply. You want to leave yourself essentially breathing room for efficiency. Even for degradation, people don't realize that power supplies will degrade over a period of time and not be able to output their peak level of performance. And so having a power supply that is overrated gives you that inherent breathing room. But essentially, this is currently the fastest Thunderbolt specification standard that is available, and it also now includes USB 3.1. So you have essentially all the cutting edge I/O that's available, Thunderbolt and the USB 3.1, and you're good to go. So just like the standard implementation in the past with other Asus boards that support Thunderbolt, there's a special header cable right here that will interface here and then plugs into the motherboard, because that's required for a signal to be aligned with the motherboard. And then from there, these will be available to you on the back I/O of the system. Yeah, because we see that people all the time is that they'll just take it out of the box and they'll plug it in. It's like, it's not working, right? You know, because it's hard. They miss just this one little cable and it's like, did you connect the cable? And they're like, oh. And so we're going to plug it into the last slot. And somebody might ask, well, why would you do that? Well, one, we want to give as much spacing as we can from a breathing perspective for the graphics card. We don't want to affect its intake airflow. In addition to that, also is that in terms of the PCI Express lanes, this slot is generally usually allocated for a by 4 base signal, which is what we want for Thunderbolt. There's no point in potentially putting it into a slot where you could either be taking up essentially by 16 or by 8 express signaling. So we're going to go with a slot that has been intended for this card's purpose. Yeah, sadly, we still almost don't have, we only have like 1 or 2 chassis, but they haven't gotten there yet for this one. Or for the USB 3, we're still going to just use the standard USB 3 header. But this one already has the front USB 3.1 header, which is a new standard. But there's very few chassis right now on the market that actually have this yet. So now we're just going to go ahead and start connecting many of the actual fan leads directly to the motherboard. So you do kind of want to somewhat pay attention, especially on our newer generation of boards. We've tried to create a number of headers for designated purposes to make the installation process easier. So on a lot of these closed loop water cooling pumps, they sometimes have their own dedicated kind of pump headers. So now on our new boards, we actually you'll see that we have one that says AIO pump header. And so that's actually where that pump would generally plug into. You want to generally follow sometimes the manual though and see what makes sense, but in some scenarios also the manual for the cooler might not actually be the optimal configuration. Sometimes the manual for the cooler will tell you to run the fans into, let's say, the pump, because the pump will have 2 like fan headers. The disadvantage of doing that type of setup though is that then you have like a fragmented fan control experience where you have one kind of software or one kind of hardware parameter controlling the fans, and then you've got the motherboard controlling another set of fans. Ideally, if you actually run every single fan directly to the motherboard, it gives you the most complete and comprehensive and consistent control. And generally the class of fan controls will be the best on the board as opposed to the more limited control for the just CPU cooler, which will probably only handle just the CPU fans by itself. So we do generally have dedicated headers like that are for just the CPU fans. But this one being a triple fan, as we noted, because it has the PWM splitter hub, it will still receive the control signal from the motherboard and then pass that signal to these 3 connected fans. So I don't have to have essentially 3 fans that are all connected directly to the motherboard because they still receive the same control signal. You know, the thing is, this fractal chassis, it's already really clean and really easy. I mean, they've got a lot of space here, so it's actually pretty easy for me to just start to wire these together and just kind of stuff them down here. So cable management really is not much of a challenge when it comes to this system. It's pretty straightforward, it's quite easy. But what I do need to do though first here is I do need to go ahead and route the USB 3 header to the actual motherboard because that hasn't been connected yet. So we're going to go ahead and do that. We've got then a USB 2 connection, which we're going to also route to the motherboard. And then from there, the HD audio, which is just for the onboard audio, will go to that header. And then we, of course, have your standard leads. So the leads right here, these small guys, are going to be for the purposes of the power and the reset buttons on the chassis. And then our front fans, of course, we've got 2 connections right here. These 2 connections are going to go to the fan extension card. So those I can do right now, and then I'll just clean up the cabling afterwards. So it doesn't matter which one you pick. They're all just seen as just standard fan headers, and we're good to go. And when we talked about the Molex connector that was on the actual fan extension card, we're going to connect a Molex power connection here. So we're pretty much at this point pretty close to being finished up, but we've got a couple of last little things in terms of some general cable management and installing some additional storage. So we've got 2 of the Samsung 960 Pro ultra high speed PCIe MVMe based SSDs, but we still need some supplemental storage as well, and so we're going to be using the Samsung 850 Pro. This one's a 2 terabyte, and this is going to go directly on the back of the chassis right here, where you have SSD mounting points for 2.5-inch drives. So the primary hard drive cage, that's going to be designated for 2 6-terabyte mechanical-based hard drives. So we're going to go ahead and just remove this. So there's a thumb screw that affixes it to there. And then from there, we'll just pretty much mount the SSD directly onto there. There'll be 4 screws that we'll need to go ahead and affix in place so that this is correctly mounted and seated. And then from there, we'll pop it back in place. We'll run a SATA cable for data and one for power, and we'll be good to go in terms of that drive. And usually, just kind of another quick tip that I tend to try to recommend is I usually go with the inset connector first, just because in the future, if you want to leave any exposed connectors, I find that it's easiest to leave the ones on the outside available to you, just because it's harder to try to find and stick a cable behind another cable and pulling it out or something like that. So I will always go with the inset, or essentially the connectors in the back first. So I've gone ahead and switched the power supply on. So the power supply had to first be switched on because it was in default and off. So I had to flip that on. And now I'm just going to use the power button that's down here, down on the board on the bottom. But once we press that on, essentially what we're going to be looking for is the debug information and what it's listing to us. So we can see right there, CPU, memory, and it's going through the initialization process. Now, normally it's attempting to, of course, register all of the individual items. And there's even actually an LED system that we have in here. It's a quick diagnostic LED, one for the CPU, one for the DRAM, one for the graphics card, one for the boot device. And if there was an issue with one of those, it will lock and let us know as well. So
at this point, is it just cycling?
No, it's processing through. So actually you can see the fans kicked on. It actually is going through the correct sequencing of essentially acknowledging that it saw the CPU okay, and it already passed 62 and 99, which would help to indicate to us that it's normal. It's actually working the way that it's intended to. So at this point, you can see already it went sequenced through also to the HD, and we hit this AO. And we can also see here at the top it's green. All these are essentially indicators that we're essentially okay. All those processes complete. But what we can see here is it did now register to us a post error. And so the post error is indicative of 2 factors. One, of course, that it didn't recognize the graphics card from initializing. Okay. And then the second post error, you actually can see, what does that look like? A little symbol like of a hard drive.
Oh yeah, no hard drive.
And that's because there is right now no active drive. So when it attempted to see if there was essentially a bootable option there was no bootable option.
Okay, cool.
But we can see that it didn't lock, take for instance like on CPU or memory, and we also don't have a lock on CPU or memory here as well. And that's because essentially there's no issues with those. So from that initial kind of assessment, we know that that is working the way that it's intended to. Cool. So the next step is now we can actually go, we'll finish getting the power for that storage device, and then from there we would next want to now then put in a card to actually check the normal post functionality. Now I'm going to remove 3 slots. I just find that it's a little bit easier sometimes when I'm spacing things out and putting things back into place. It makes it a little bit easier for me to work in terms of removing 3, even though I will only need 2 because it's only a 2-slot graphics card.
So these, I have 2 6-terabyte drives we're reusing. What are we up to now? I mean, I bought those like maybe a year or 2 ago, maybe 2 years ago. What are we up to now? Is it like 8 terabytes?
Actually, you can get 10. So 10 is kind of like the peak. It is still a little bit more in that rarefied territory because it has a little bit of non-traditional height clearance in terms of it being taller.
Oh, really?
Yeah, and that's just because they're stacking.
More platters?
Yeah, they're stacking more platters and some of the different designs. So I'd say in terms of normal convention, right now 8 terabyte is kind of the standard peak capacity, but you can still get, I mean, a 10 is an option. When you talk about, of course, the demands of a professional workflow, there is no argument when it comes to that. If you want, you know, the fastest performance possible, the best response, the lowest latency, then, you know, these latest generation drives like these Samsung Pro drives, the MVMe based solutions, the PCI Express based solutions are really just offering that best experience. Okay, so we've got two in there. We are going to leave an open spacing between these two to just allow for a little bit better cross-directional airflow from the intake fan that's right here in the front. But there will still essentially be an option so that at a later time, if you did ever want to put another drive in there, it would be up to you that you could still mount a third drive into that drive cage. So we've gone ahead and completed the post at this stage. So that's the initial power on self-test. Nothing errored. When essentially what that is just confirming for us is that all the key components were initialized. The CPU, the memory, the graphics card, the M.2 based SSDs. The mechanical hard drives they're not visible because we haven't connected those yet because we're still going to install the operating system. So I've left those disconnected, but otherwise everything looks entirely okay. So what happens is we actually have already entered in the UEFI or the BIOS. We just hit the delete key to be able to enter. And so we're seeing the easy mode interface. And this is just essentially the confirmation screen for all the initial aspects of what is running on your system. So right off the bat, we can confirm, of course, it's a Prime X299 Deluxe motherboard. Here's the version of the UEFI or the BIOS. We will be updating this to a more recent version so that we just have the best stability, functionality, all those different aspects. CPU, it would be registered here. Now, we actually are going to be using a 7900X, not a 7960X. This is actually the actual flagship CPU coming shortly from Intel, so it's an unreleased part. So we actually had the incorrect CPU shipped for purposes of this, but you guys might be able to maybe see some performance testing with this part, so we'll see how that comes along. But for intents and purposes of the build, this is essentially somewhat irrelevant. You will essentially see the correct part listed there once whatever CPU is you're using. So if you're using a 7800 series, 7900 series, whatever it is, it would be listed there. Your density for memory, so we're using 64 gigabytes, we can see there. But the interesting thing here is you'll see that it's registering at 2133. Yep. And that's because that's the default operating memory speed. It is not the XMP operating memory speed, which is 3200. Now we do have a one-click option that we can just go here, and if we click Profile, this will actually allow us to set the, you can see, XMP setting. So that would be DDR4 3200. And so upon reboot, the system would automatically apply that correct speed to your 64 gigabytes of memory. We can confirm here that we have actually all of our fans correctly connected and running. So we know that we have our CPU fan, which is controlling our 3 fans in our system. We have a chassis fan here, and then we've got the 2 front intake fans. And here it's registering to us all in real time, the actual RPM, so everything is set. We're good to go there. And if we want to make any adjustments even right at this stage, we could jump into the fan control settings. SATA information, because we don't have any right now default SATA drives connected. We don't see any.
Because you disconnected all of them.
Right, we don't see any drives listed there. That's entirely normal. We have the default motherboard temperature. Now, if you had maybe messed up, made a mistake, hadn't connected the right fan, there wasn't power to your pump or something like that was irregular, this would be significantly higher, maybe like 55, 65, 70 degrees. And you would probably seeing it keep actually increasing until the system would actually probably just shut off because it has a thermal policy that says, if I get too hot, I'm just going to shut off just for safety purposes. So you can watch this, and this actual color would change depending on the heat. But right now, since everything's fine, it's white, it's 30 degrees. That's entirely normal. We have no issues there. So essentially, you asked earlier about this when we talked about like updating the UEFI. Yeah. And so one of the really nice things now that we have is we have a built-in actually updater within the actual UEFI environment itself. So we don't have to actually go to a secondary system to download the UEFI, put it on a flash drive, then bring it over and either use the USB BIOS flashback technology or have to do anything like that. We can just essentially go, and you see now you have 2 options for internet updating. One says via storage devices or one says via the internet. So we can connect via the internet, and by default, generally in most situations, it should always be DHCP, and we'll just click next. And once we click next, it will attempt to essentially reach out to our server, and you can already see that there's actually a much newer version, 702 versus 0218.
Okay,
so it tells us, yeah, we can see the original date build here was what? Is 06/01/2017, and this version is 08/08/2017. Yeah. So essentially August 8th.
Like 3.5 months. Yeah.
So it's now telling us, hey, I already downloaded the BIOS, the UEFI update. Do you want me to go ahead and apply it? You click yes. And now it will complete the actual flash process. So you can see it's a very simplified way to now be able to handle and make sure that you have the latest UEFI, which is very important. When you go about completing your system build at the very beginning, we always recommend that before you start the process, make sure to update the latest version to make sure that you get the best interoperability, compatibility, performance. There's a lot of different things that we do with the UEFI that sometimes it's internal, sometimes it's working in conjunction with partners, with Intel, just to make sure that the overall best experience is possible. So you definitely want to do it.
So when these new platforms come out, you got an X99, now we're at X299. There's got to be some point at which, you know, maybe the first week or the first month, like the early adopters get in there and they're like, you might be pulling their hair out a little bit, maybe.
Yeah, I'd say small now. We try to do a lot of testing.
Yeah, I totally get that. But where would you say would be safe? Like, is it 2 months in or is it 3 months in where things are going? Because obviously now that's 6.1 and we're 3.5 months later.
Yeah, it's kind of tricky because it depends on how much technology might also be aligned. So this platform, there's a lot of other technology that has kind of been aligned to come out with it. So really fast memory kits have come out, the synchronized lighting technologies that we had, there was a wireless controller, Intel Optane, there's all these other kind of little things that can influence the number of patches or release. But I'd say normal convention would generally say that after about 3 months. I'd say once you hit about the 3 month period, you generally see a very mature UEFI release that in most situations you're probably not running into any overall kind of teething or inconsistencies that might be present. I'd even say that probably for the vast majority, I'd say even pretty comfortably at 2 months, you're pretty solid. But 3 months is I'd say very solid. Overall, at that point, UEFI releases that tend to occur after about a 3 month period tend to be very targeted. They're for specific, maybe new components that get released, so maybe a specific new type of memory module, a specific type of issue that might be very isolated to specific users under different configurations. It tends to not be as broad, as large, or it's not going to be as performance-centric, where, you know, the first 3 months we might still be just doing fine-tuning and continue to optimize performance and do things along those lines. So yeah, I'd say if you're one of those people that do want to hedge a little bit, you know, doing it up to about that 2 to 3 month period will help to kind of ensure you get the most mature UEFI. So you can see that was entirely automated.
Yeah,
it let us know that it completed the process. It's gone ahead and flashed, and now it's going to go through a couple of reboots. Now, it is important to understand, depending on the length of the update period, the more that it is, or excuse me, the longer that it might be, there could be actually more update microcode, essentially. And when there's more update microcode, that flash process, the time between it rebooting once it ends, can actually be longer. And sometimes there might even be multiple reboots. So you actually, this is not always going to be something you would see. It tells you BIOS is updating LED firmware. There might even be some other kind of messages that come up. Essentially, do not touch the system, do not do anything. Wait until it's entirely complete and it will let you know. When it's essentially stopped and it's no longer rebooting, then that flash process is completed. Sometimes you might just have one reboot and it'll go straight back. But if you notice there was actually already 2 reboots. It went to one initial one and then now it's going to another. And so it will continue that process depending on the number of kind of subtle, specific levels of firmware that we're updating. Because we could be updating one specific controller on the board. We could be updating management engine firmware for the CPU. We could be updating the option ROM software, which manages the PCH and certain RAID functionality. So there are, depending on that length, the longer you are, you know, if you're going from, let's say, you know, a build, let's say maybe you build this system a year from now, right? And you get a BIOS build and you would have gone from 0 to 16, you might have a few reboots because it's got a lot of information that it's going to be patching through. So just kind of keep that in mind, that if it does take maybe, you know, you think, oh, it should only take 30 seconds because somebody says it should take 30 seconds. That's not necessarily always the case. It could be even maybe, on average, it probably shouldn't take more than about 2 minutes, I'd say at the longest stretch, but it could maybe even take up to something in that range. So at this point, the UEFI has gone ahead and completed its update. We can see right there, right off the bat, 0702, that it's a confirmation that essentially we now have that latest build. So now it's just asking us, because it's gone ahead and completed it, everything's at defaults. So at this point, we would just hit delete or F1, either one, and then that will allow us to get into the UEFI to load our defaults and reconfirm essentially everything that we did before we did the actual update, right? Nothing has really changed. We can still see CPUs listed, BIOS version, UEFI versions listed, the memory, but because it got reset back, it's no longer at the XMP value that we actually set when we rebooted the system. before the flash started. It's now gone back to that baseline 2133, and we can see temperature. Of course, the system's warmed up a little bit, but it's still essentially letting us know everything's working the way it's intending.
34 is good.
Because we're at 34 degrees. And keep in mind that we're at almost the upper echelon of heat generation now because of the CPU that we actually have. So this is even more than what we would traditionally be looking at when we originally targeted the 7900X, which has quite a number of less cores and threads. So at this point, we're pretty much done. We're just going to load our defaults. I don't ever recommend even setting XMP or any overclocking parameter when you first install the operating system, because if you run into an issue during the operating system, there's a crash or some type of issue, you may not know why you experienced that crash. Okay. So I generally always recommend just use the pure default perspective when you go about installing the OS, and once you've verified that everything is working normally, at that point then you can proceed to go ahead and turn on your XMP if that's all you want to do from a performance tuning standpoint, or of course if you want to jump into the auto tuning to start the auto overclocking process, then that's also something you could kick off at that point. But at this point, now we're just going to go ahead and start the OS installation. So we're going to get the operating system installed here. So we've got Windows installed on a USB flash drive. So it's now going to be, it's connected to one of the back ports, and we're in the UEFI. Now, one thing to keep in mind is that if we were to just automatically restart the system, it would boot by default straight into this drive. You don't necessarily want to do that. And the main reason why is because by default, it does not boot into a UEFI installation. And the reason why this is important is a native UEFI installation, one, helps ensure a faster and quicker and more secure post and boot, and also will ensure that the system is set up for what's called GPT hardware. And that's important, especially in this type of system where we have large density hard drives. If you don't do native GPT installs, you can be limited to 4 GB hard drive blocks. And so because we potentially are going to have not only 6 GB, but who knows, maybe bigger drives at some later date, you ideally want to make sure that you do a native UEFI with GPT installation so that you can have high density capacity support.
Yeah, this is all new to me since I've never had an MVMe before.
Oh, well, this would be for actually any Windows installation.
Oh, really?
So even if you were just installing on a standard SATA drive, you would want to optimally have the fastest performance. Right. We actually did this when we did the last build also. But, it's just one of these things that sometimes I still see people, they're not necessarily aware of. They just kind of go with the default in Windows installation. And there's nothing wrong with that. It will work. You're just not necessarily optimally taking advantage of all the hardware. And the main reason why this exists is you sometimes have newer devices or older devices. Maybe you have a newer board, but maybe you've got a graphics card from a few years ago. It might have something that's called a vBIOS that doesn't support UEFI. So technically, when you do a native UEFI install for Windows, every single device that you go has to generally support that UEFI policy. So that generally means only newer generational hardware. But this has become fairly standard over the last few years. So for most intents and purposes, unless you're running something very legacy oriented, I say you probably shouldn't have an issue in terms of doing that. And if we actually look here in the UEFI environment, we'll see that there is a listing for our install drive, the SanDisk drive that we're using here. It notes one is being a UEFI version and one a non-UEFI version. And so we actually want to select the UEFI as being the primary boot option. And so that's the one that we're going to boot to. So that, you can see we could play around with this, like we could move that one to the top.
I didn't know you could do that.
But we're going to keep this one at the top because that's the one that we want to initially boot towards. So at this point, we'll just save and reboot, and it will now automatically boot into the drive, but it will boot under that UEFI installation policy. Here in our system configuration, right, we've got the two drives. So we've got the Samsung 960 Pro 512 GB PCIe NVMe SSD, and then we've got the 1 TB here, which is not visible, but it's directly underneath the M.2 heatsink that's installed here. So that's the one that's going to get the primary operating system installation.
Okay, it's the one under. Yeah.
Correct, underneath this heatsink. And we didn't note it in our build. Really for us, I don't think it's going to be necessary, but for users that are super critical, or maybe they have more restricted airflow considerations in terms of their environment, or they have extremely hot ambient environments, there is actually right down here an optional M.2 fan header. And that's because we have the ability to actually have an M.2 fan mount for a 40mm fan, so that you can actually even connect that directly to that and provide direct airflow even to the heatsink, even further increasing its airflow capabilities. So click on install, pretty straightforward. And this is going to be all pretty quick. When you're using a USB 3 flash drive, you're good to go. we'll input the key later, so we don't need to worry about that. You're using Windows 10 Home.
Yep.
So we're going to click Next here, and we're going to be presented shortly here with the option to essentially partition and format our volumes. So we don't need to upgrade. We're going to do a clean custom installation. And we can see right here that there's one primary drive that's listed, which is fine. That's that 1 terabyte drive. We can see that it does not have a partition. It does not have a format. So all we need to do is click New and click Apply, unless you wanted to customize the space for some purpose.
Okay.
But of course, you can always do that after the fact. Now, a quick tip to verify that you are correctly using GPT and native UEFI installation is you will have 4 partitions. If you essentially go in your partition and you find that you have less than 4 partitions, you have not actually completed a UEFI GPT installation. So this is kind of the easiest way to know that you did it right.
Okay.
Yeah. If you don't see this 4, it's non-negotiable. It doesn't matter whether it's a SATA SSD, M.2 SSD, whatever storage device you're installing on. If you don't see 4, then you haven't actually booted into that UEFI GPT install. So at that point, it will auto-select the correct drive for us to format as being the primary drive. We're going to click Format. Depending on the capacity, different variables, it'll take a second. It's done. And at that point, we click Next, and we'll start the install. Ta-da! All right, we're good.
We're in day number 2.
Okay.
We've got pretty much everything put into the box, right?
Yeah, we still have a little bit. I mean, I think there might be one drive that still might not be connected, I believe. Oh no, I think we actually have all the drives connected. There's still a little bit of cable management left to kind of just button up and finalize, but we've got all the hardware is essentially posted, verified. We ran actually some quick stability tests to verify the CPU, the memory, the graphics, everything was stable. That passed all initial stability tests, so we're solid on that part.
One of the things we didn't get on the recording yesterday, which I think might be kind of interesting, you could keep it recording.
Oh, okay.
Is this thing that you did here, this tall column of stuff, and the order in which you did it? Because I don't think I recorded any of that when you were flying through that really fast when you're installing all the drivers. Just for the people out there, can you just show the order of what you did yesterday? Like after, I wasn't filming at that point because we didn't have any screen capture program.
Yeah, no problem. So normally this is one of the most common questions that kind of people ask is what's that correct or optimal order to go about doing drivers? Now, usually if you actually use the CD that comes with the motherboard, there's actually an automated installer that goes through actually the correct sequential path. But the problem is if you don't have an optical drive, then you're not going to use this. So you're going to probably just download the drivers manually, but you might not install them in the correct order, or let's say the optimal order. So the first driver that I actually have is the chipset driver. So the chipset driver is kind of the core, essentially, driver information for the motherboard and for its corresponding chipset. This is important because when you generally complete the Windows installation initially, you'll find that you have tons of exclamation points. And you'll see that you have all these things that say like processor, integrated memory controller, registers, PCI Express root buses, all these type of things. This driver essentially does all of those, so it handles all that. So think about it that if you don't lay this foundation of all those devices correctly being initialized, devices that have to initialize with those may not work correctly. They can work, but they may not work the way that they're supposed to, and you can run into certain issues. It's also very common that when people tend to have sleep and hibernation and power-related issues, it's because they probably haven't installed the chipset driver, which has a lot of
I've had those issues
aspects that relate to sleep and hibernation.
That was probably me.
Because Windows will work by default without this driver. It's just it's not optimized. Optimized for it. Your next one is going to be what's called the management engine driver. Now, I will state that it is generally important to reboot in between each one of these kind of core drivers. Later on, for some of them, it's probably okay that you can install 2 or 3 at a time and then reboot. But for the first couple, you do want to reboot fully between each driver. So chipset, then management engine. This is specifically for the CPU. There's a management engine firmware that's part of the firmware on the motherboard. It communicates with the CPU. It's an important driver that's CPU centric, so you need to have the management engine driver. Not for all CPUs, but for this specific one, we have that Intel Turbo Boost driver. So this is an optimized driver specifically, again, for the CPU. Again, best performance, you need to make sure you have that driver. Once you've kind of completed all these, you could probably reboot the system independently between each one, but going forward, we can probably start to do a couple at a time. Next one is the Intel NIC driver. So this is for the 2 Intel network controllers that are built onto the motherboard. We've got the GeForce driver. Now, I do recommend that the graphics driver be installed independently and on its own full reboot. So the reason why is this also precedes the audio driver, and that's because the GeForce, while you think it's graphics, it does have HDMI and it does have its own audio controller built in. And so we want to have all its audio initialized independently, and I don't want to install another audio driver at the same time while I'm technically installing the audio driver for the graphics card.
Gotcha.
So we install the graphics, then we install the dedicated audio driver. Depending on whether you need it or not, you have the networking drivers. So this is for the Wi-Fi. Depending on how we've packaged the driver, you may find that there's the Wi-Fi and Bluetooth included together, but many times there will usually be one for the Wi-Fi controller and another for the Bluetooth controller. Okay. And I do stress that when you go into your device manager, if we do this as a reference, you will find that don't always look for an exclamation point to be an indicator that the driver is missing. Take for instance, your audio driver will look 100% installed. It will actually just say high definition audio. But until you actually install the Realtek audio driver, it will not say Realtek high definition audio driver. So it's kind of like subtle because you might think that it's quote unquote installed, but it's actually missing its software. If you want to be very, very technical and verify everything, you can always check the version number of the driver, like we just did with the Turbo Boost, on what's actually installed. So you'll see like 8184. You can then go back and actually verify. So you can see here 8184. We know that that is the driver. Okay. So those should always link up. You should always see.
That's good to know. I didn't know that.
This version should be that version. If for some reason you see something that's probably much, much older, it's probably because it's referred to as what's called a Windows inbox driver. It means that Windows shipped with that driver and it's not the correct optimized driver. Next we have, this was an optional piece of software, but I recommend it. It's the Samsung software utility, which does performance optimization, benchmarking, performance recovery, but it also allows you to update the firmware. Many times you'll find like if you're buying an SSD, it could have been out there in like the quote unquote, you know, the channel in some distributors inventory for months, right? And what happens if the vendor essentially has released a performance improvement, stability improvement, some type of firmware. So you just essentially want to install this, and once you install it, you can open it up and check to see if your firmware is up to date. So for instance, we open that and we can check right here, we have the latest firmware, but we actually did not have the latest firmware, but we did already update it. But you can, you could cycle through your drives. So example here,
exactly.
We do have an older drive that Dave had that he hasn't actually updated yet to the newer firmware.
Yeah, and it's running slow.
And so you would just click that button and generally would reboot and you'd be good to go. Now we are using these ultra-fast Samsung 960 Pro MVMe-based SSDs, and Samsung has continually kind of optimized their performance and other aspects. And because they're specifically NVMe, they require their own NVMe enhanced driver for the best performance. If you don't use this, again, the driver will 100% work, but it will not take advantage of the NVMe protocol that's offered on this chipset. So you do actually have a separate standalone driver. This one I did not download from Asus's website. Why? Because we don't know what you're using and we can't supply that driver for you. So that driver we actually had to download directly from Samsung's website. So just keep that in mind. Not every vendor though has the time or the bandwidth to develop a driver though, I will state. So even if you get an NVMe driver, it may not actually, you get an NVMe SSD, it might not have an optimized NVMe driver. So it is something to be conscious of. And last one was an optional driver, which isn't probably for most systems, but we specifically have a Blackmagic mini monitor add-in card that we also installed the driver for. So, I did miss one. And this one actually would probably go, in this sequential order that I had, probably right before I was separating it here for when I was doing some other things, is this one, which is the Intel RST driver. This is a very important driver as well. That's specifically the SATA and storage control driver offered by Intel. So that is 100% required and recommended to make sure you get optimal storage performance and functionality. Okay. So that should be kind of your optimal. Or if you notice in the very beginning, almost all of them are all the Intel-based drivers, and then everything goes after that. So when you actually, after I finished up the initial install, you had gone back in and put in a couple of applications. One of them was CPU-Z, which was a free utility. You can use CPU-Z for this purpose. I'm using Ada64, which you can get a trial version for. I do actually recommend for a lot of people across the long term. It's a really good application, even if you pay the long-term license fee for it. It's only at $30 to do things like stress testing, checking your hardware. It's a good utility, I think, for any, I think, moderate to high-end system that you probably have this utility. But a good compromise in between the two is probably something like CPU-Z and something like our ROG Realbench application. Mm-hmm. You can accomplish very similar kind of results. But for me personally, I like using Ada64, so that's what I'm going to be using for this. But I can show people how they could reference the same information through CPU-Z. So I'm going to open it up here. I'm going to go to Tools. I'm going to go to here to the CPU ID. And the CPU ID is going to tell me the CPU frequency. But down here, we can see memory type. It's one, confirming for me something that's important, which means it's quad channel. Mm-hmm. So that is one thing that we want to confirm. And now it's also confirming for us for the frequency. So DDR4 3200. So we know we're now operating at that new XMP 3200 speed. For the little bit more technically minded individuals, it does also tell you right next to that the corresponding timings. So those are the operating parameters for that speed of the memory. And if you really want to kind of be super technical and check, you could check like the memory kit box that you have and should see that those should generally line up for most intents and purposes. So if I go to CPU-Z, CPU-Z is going to be pretty much the same, but they're going to read it out a little bit differently. And for some people, it actually might be a little bit more confusing on how they present the information. So we have the CPU tab, but we need to go to the memory tab. And when you go to the memory tab, it will tell you quad channel, but DDR is double data rate, and so they won't reflect what's called effective data rate. They're going to report to the non-effective data rate, which still has to be multiplied. So you see that's 1600. Mm-hmm. So you might be confused as like 1600.
Yeah, that is confusing.
I need to actually do something else. No, you have to multiply that by 2, and by multiplying it by 2, you get 3200. So it's the same information, but again, that's why I like Ada, is that they're actually clearer in terms of the way that the information is presented. But both are confirming for us essentially that we are in quad channel and 3200 speeds. So the last thing that I want to do here, well, it won't be the last thing, but I do want to quickly check is just make sure that I have a guaranteed uplift. So I'm going to run a quick benchmark, and we'd already run a previous one at stock. So I'm going to pull up my stock benchmark here. You can see that we have 85,000, right? And I believe somewhere in the 60,000 range when we were at 2133. So with Ada, I also have the ability to do of course, the memory stress test. So I'm going to run a quick one there, but we'll do one within Realbench. Also, because Realbench will use the entirety of the subsystem as well. But we're just going to quickly load this up. I'm going to open up my task manager. And I like to open up my task manager because I like to just confirm to make sure that the CPUs are being loaded and that the memory is actually being loaded. So we're going to see right now that it's all of a sudden memory is going to start kicking up, and now we're just going to start eating up all that active memory. Now this is one of those scenarios too that remember when we were originally talking about your build, depending on how much you actively utilize your memory. Like I would say an editor versus somebody that's editing and uses a lot of After Effects.
Yeah, associate right? After Effects, yeah.
Take for instance, probably wouldn't have to be as concerned about what the temperature performance is on the memory with sustained load, right? But an After Effects user might actually be more concerned with this because the memory actually, like I said, over time could produce instability if it maintains super hot operation. So like right now, if we probably touch it, it's a little bit warm. But I guarantee you if we come back to this after a little bit of time, it'll be much warmer. Okay. And so that's kind of one of those things where if you find you build your system and you're finding that you generally don't crash until like you're working for like 3, 4, 5 hours, and you're working consistently like on a big After Effects project, or you're working with something when you go into your memory and you're seeing, oh, I'm using 32 gigs, I'm using 40 gigs, 50 gigs worth of memory. that's an indicator that it's most likely, especially because it was working for a long period of time, not a question of issue with stability per se in terms that it's not stable operating at that range, but because it's becoming unstable because the fact that the temperature has increased considerably. And then that's where you might need to focus at going, what can I do to improve the cooling specific for that? That might be where, like I said, if the memory modules that you purchase, like the ones that we do have here, they do come with an optional fan mounting kit. Maybe you want to install that. Maybe you want to install, there's like angled fans that you can put in where you can actually get like a fan that mounts to like one of the mounting points for the motherboard, and you could just angle it directly on there. There are some chassis that have actually side mounting fan points so that you can just blow the airflow directly onto the component. So it's all up to you, but you ultimately just want to help to introduce more airflow.
Well, you're pegging the CPU, but I don't hear this ramping up at all.
Yeah, well, we've got we're still running effectively at a pretty close to stock on the CPU. And so the cooling solution that we have here should be generally fairly comfortable up to about 280 to I think even 300 watts. So since we're still at around the stock thermal envelope.
Because isn't it saying, does that say 54 degrees?
We can see the maximum is right here. So one of the cores always vary. In terms, some cores run a little bit harder than other cores. So we can see one core is peaked at 69, but overall it's important to keep in mind that's only a peak temperature. What's more important for us to look at is the overall average temperature over time. And we can see that right now the average is, they're starting to stabilize, but you would want to monitor that more like after it's been running for like 15, 20 minutes or something like that. But we can see it's actually quite cool. We're looking at 52 degrees, 50 degrees.
Yeah, it's not bad
average.
for being pegged.
Yeah, for being right now, where if we look right now, essentially every single one of the cores is 100 load. All the memory is 100% load. This is about the worst case, quote unquote, scenario you would generally have for when you're using your system. So to have your system be this quiet and this cool, it's a great example. And that also opens up the flexibility that we know that right now, if I bring up, like take for instance, the CPU monitor, it will actually tell me the confirmed CPU clock, right? Which we actually can tell already is right there. It's also telling us that it's 3.6 gigahertz. Because my CPU is running so cool, we know that we've got that margin, right? As long as the frequency is actually there, that's going to be a golden example of, we know, hey, temperature's not holding us back. We can do some overclocking. We can get this maybe, 3.8, 4.9, 4 gigahertz, right? And get even more threads running at a higher frequency and still be at a nominal temperature to ensure long-term reliability.
All right, so JJ has buttoned it all up. Everything's inside, the drives are all good. I even had JJ sign it, which I think is pretty darn cool because he did all the work. I think that's pretty cool. I got a white case, got to sign it. So what are we gonna do next?
Well, pretty much we're gonna start, I think, one of the fun parts, which is gonna be overclocking the system. We've already gone through and essentially stress tested it at stock, made sure the system was stable, checked the CPU, the memory, the graphics card. We then enabled the XMP, which would be our next normal step. So we verified the system was stable with that overclocked value for the memory. And now we essentially want to take it a little bit further. We want to take a look and see how much more we can get from that CPU. So normally at this point, I would recommend that we kick into our auto tuning software, which is part of our 5-way optimization suite in AI Suite 3. It's something that we showed last time and that you actually used on the X99 platform.
Because I'm of the level of experience, I don't know how to overclock like other people do with voltages and offsets and stuff like that. It works quite well.
Yeah, and
at least what I can see, it works quite well.
It definitely does, and one of the key benefits is that it's real time. It's specific to your CPU, to your cooler. It accounts for something that's called the silicon lottery. But the challenge that we have here is, of course, the CPU that we're using right now is the 7960X, which essentially is an unreleased CPU. So the software essentially is not ready yet to automatically overclock that CPU.
We accidentally got the wrong part with the 16 cores instead of 10 cores. I don't know if they'll let me keep it or not, but we'll see on that one. But yeah, since this is 16 core, it's not going to be out for another 10 days.
Yeah, for about 10 days. Okay, so we've gone ahead now, jumped back into the desktop. We've loaded the system at 100% pure stock. So that means that we don't even have what's called the Asus multi-core enhancement, which would give us a little bit of additional performance for free. So this is pretty much running 100% pure Intel spec. So for all intents and purposes, you'll see that the CPU frequency right now is dropping down to its lowest level. That's normal because that's part of what's called Intel speed step, and it will go up to a certain frequency once it's under full load. Now, one of the really interesting things about the Intel's latest generation on Skylake X is there are certain CPUs that have something that's called not only turbo but Turbo Boost 3.0. And that allows them to even get even higher levels of single thread performance. This isn't important because normally when we would go about overclocking, which we haven't yet gotten to really fine tune and maximize total performance, not just for multi-threaded applications, we would want to do what's called per core overclocking and maybe have a couple of cores having at a higher frequency than all of our cores. But for right now, we're essentially going to show you what the peak kind of all load frequency is if we were just running from a base perspective. So we've got that to show you essentially in two quick ways. Right now you can see that it's pretty much idling. There's no load that's present. We can see all our cores are essentially waiting for something to happen. So we're just going to use Cinebench as one initial reference, and we're going to do the all core. So with all cores, it's going to ramp up, it's going to see the load, and we're going to see an overall maximum here of about 3.2 gigahertz. So that you would see in quite a number of heavy load applications. But this application does not use something that's called AVX, which, like I said, in Premiere Pro, if you went into doing certain loads, it would actually be even lower than that because AVX comes into play. So a way that we can simulate this is by using our stress test with AIDA64. When we kick start, this is going to really hammer the system right now, and it's going to even have that frequency even come down a little bit lower.
And just real quick, the score of 27, what is that, 68?
Correct.
Is actually faster than the overclocked of my previous system from 3 years ago.
Which would make sense because we've got a significantly higher level of cores and threads.
Yeah.
So it goes to show you
twice as many.
Yeah, so that shows you where, you know, when you have an extremely high level of threads, you can really beat frequency. But ideally you want both. You want high frequency and you want a high number of threads. If you got both of those, then whatever you're doing, you're going to get a great experience, which is part of the reason why we overclocked your system, because we were like, hey, you can still benefit it from when you're doing your photo editing versus doing, you know, your rendering, or you're doing whatever it is that you're doing, you're going to get a better experience. So we're going to click start right here. It'll take a moment. You guys will essentially see everything start to get under full load right here. And we can already see that we're just about pegging out. It's going to take a moment for it to stabilize, but it'll be around like 2.8 to 2.9 gigahertz essentially.
And I know we've kind of gotten used to this already because we've been staring at it, but look at all those boxes that represent cores.
Yeah.
Or threads.
It's just a massive number. So we can see that at this point we're hitting essentially that max of 3 gigahertz, so that's 200 megahertz under, right? Yeah. The 3.2 that we saw when we were running Cinebench. So at this point, we want to see effectively what we can get towards. Now, this is a little bit of uncharted territory because it was a new CPU. Even for me, I've had limited time access to be able to try around with it. But based on the kind of the overclocking capabilities of what Intel has had for the Skylake X series CPUs, we feel pretty confident that we can definitely get at least a gigahertz, if not more, out of this. So we're going to now go into the UEFI, and we're going to increase performance by enabling our XMP for our memory. So we're going to jump up to XMP 3200 speeds, so that's going to be quite a bit faster. And then we're also going to drive up that CPU clock frequency and see what we can get out of that. All right, so we've gone ahead and now jumped back into the desktop. I've done a little bit of work in the UEFI. Now I will advocate, I'm an enthusiast, I know what I'm doing, but I've still only had a pretty small amount of time to actually really test what I could really tune it out to, but we've gotten to a pretty reasonable level. We're at just a little bit shy of where your total overclock was. And I believe your overclock, well, it might have had 4.3. I'm pretty sure you think it was, it was a per core.
That was per core, not all cores.
Correct. So still on a total all core, I believe it would have been a 4.2, and then some of the cores would have been set to 4.3, which is how we originally discussed setting it up back at that time. So I think that's...
Which is impressive because we got double the amount of cores and we're about the same clock speed.
Correct.
At 4.2.
Yeah, so overall, I think a pretty nice overclock. If we take that from, you know, just the face value that effectively our maximum under the highest workload was about, what, 3 gigahertz, we've essentially gone now essentially 1.2 gigahertz overclock. And on top of that, we have of course, the 3200 on the memory. And that's definitely nothing to sneeze at because the memory controller for this Skylake X CPU is quite strong, so it gets even more capable in terms of not only increasing clock frequency, but memory frequency as well. So we're going to go ahead and now rerun the Cinebench and see where we're at from that perspective, and see what where we're running here. So we can see right here, we got the 4.2, and we've got the 3200 for the memory. And you can already see in it, you can see it moving along very quickly.
Man, it's moving.
Yeah.
Doom, 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 doom.
And yeah, so we can see that's 3600. It's a sizable increase over, I think the previous was about under 2700.
Yeah, if you bring up that spreadsheet.
We can see here.
It's that fourth tab, I think.
Oops.
Or maybe, yeah, that one.
Yeah, there we go. So
there it is.
yeah, so we can see here.
We went from 2,800 basically to 36.
Yeah, so that, quite of a sizable increase there. And now, just to guys show you that also, of course, the core benefit of implementing some type of overclocking is we'll just run the quick stress test and you'll see that there won't be any deviation here in terms of the actual frequency, so it won't change. Now, ideally, when we would run the auto tuning application, there would be some difference because auto tuning by default will do a per core overclock. Okay. Right now, all of our threads are essentially forcing themselves to run all at 4.2. Given more time, we could though even get a couple of these additional threads to higher values. So maybe running like one thread, maybe at 4.5, two threads like at 4.4, and then maybe like four threads or something like that at, like 4.5, then 4.4, then maybe 4.3, and then everything like at 4.2. That is all varying amongst, of course, the CPU and your cooling and everything along those lines. But of course, the system that we built here, we really wanted to try to make sure that we weren't limiting that possibility of trying to be, I'd say, fairly aggressive in terms of our overclocking capability. So we'll click on that. And we're going to see, of course, now all the CPU is going to come under load, and we will see that that CPU core frequency is essentially staying exactly the same. And we're also, of course, you can see right here for the memory, fully loading all the memory. So it's also indicative to show you that the system is capable of essentially being able to handle this type of overclock.
All right, I'm going to do some benchmarks, and I'm going to be comparing mostly my old system, which had 8 core, to this new system that has 16 core. Because I have a feeling a lot of people maybe did what I did about 3 years ago and got a new computer build with an 8 core part, and they're wondering, is it worth it to go to 16 core? So I'm going to be showing a lot of benchmarks in that regard. So the first one is Cinebench, which is a pretty good measurement tool for both the CPU and GPU. I've got it set to all core. Both are overclocked. The old computer is overclocked to 4.3. The new computer is overclocked to 4.2. What you see here is the 8 core part is listed in blue for my old computer, and the red is the new 16 core part. And as you can see, yeah, the new computer is totally crushing my old system. All right, next up, we're going to actually compare this 16 core computer to Max Urev's 16 core Threadripper part, because I have a feeling a lot of you are out there thinking Intel or AMD, which way do I go? So I thought I'd put this graph up here. I thought this was kind of interesting. Now again, I don't know the pricing difference between the two, but I have a feeling the Intel chip is probably going to be a lot more expensive. But as you can see, it's slightly beating it. And really, these computers are not on level playing fields. I'm not doing any sort of test bench scenario where I'm making sure all the drivers and everything is identical and using the identical parts. So it's not going to be exactly the same, but I think this graphic at least shows you that they're both pretty close. All right, now going back to comparing my new 16 core build to my old 8 core build. We're going to be using another benchmark called Realbench by Asus, and it simulates real-world tasks because it actually uses real-world programs as it goes through its benchmark. And as you can see, the Intel in red does beat my old 8 core in blue by about 28%. Premiere Pro has a really nice drop frame indicator that Resolve doesn't have, and the drop frame indicator is a great way to judge performance of playback. So lower drop frame numbers in this chart is better. Each one of these tests uses a different codec and resolution for camera that you might use. Each test is for 1 minute of playback. At the top, you can see my old 8 core in blue with 4 4K XAVCS streams running on a 4K timeline dropped 10 frames for 1 minute of playback, while the new 16 core didn't drop any frames at all, which is really good. Next up is my GoPro at 1080/60, just a single stream. But halfway through, 30 seconds in, I reversed the clip so they're actually playing backwards, which usually just kills any CPU. So lower is better in this chart. And as you can see in blue, my old 8 core dropped 1350 frames, while the new 16 core only dropped 1167 frames. Next up is red 5K footage on a 5K timeline with at least 1 telemetry correction. Both didn't drop any frames, which is pretty amazing considering this is raw footage. All right, I might have done something wrong on this last test because it doesn't make any sense, but I'll share it with you guys anyway. I'm using the Mini Ursa 4.6K raw footage, which saw 470 drop frames in 1 minute on my new system versus only 142 on my old system. Remember, lower is better in this case. I'll say that within Resolve program, which does, Blackmagic and Resolve are made by the same company, I played back this footage and there was absolutely no drop frames, which I guess could kind of be expected since it's their camera and it's their software. But I don't know why. I tried it many different times and I just couldn't get it to beat my old system within Premiere Pro. And I just want to add, for both Premiere Pro and Resolve, these tests, nothing has been cached. I've turned all caching off, so there's nothing happening in the background, at least that I know of. All right, let's talk about rendering times, because everybody likes to know how fast it's going to render. In my old 8-core system in blue, and lower is better by the way, for XAVC-S, the 16-core new system beat the old system by about 28%. For the GoPro footage, there was a much bigger difference, where the 16-core system was 48% faster. The 5K red footage was 46% faster on the 16-core. And for the Mini Ursa 4.6K, had the lowest percentage difference of only 11%, where the new computer won out. The candlelight benchmark done with Resolve shows just how much Resolve loves GPU power. In this case, bigger is better and blue is the 8-core. Since I use the same 1080 Ti card for both the 8-core and 16-core systems, you can see the results are almost identical for the blur nodes. And yes, you can read that it says it can play 60 blur nodes in real time, which is pretty amazing. When we get to the temporal noise reduction, you can see that the 16-core system pulls ahead with 17% more frames. All right, staying in Resolve, I have a project where I'm using the demanding match move tool, which is new to Resolve, and it's pretty cool how it works. It basically lets you do compositing and tracking without having to leave to go to Fusion or After Effects, which can be a real time saver. In this case, higher frames per second is better, and 16-core is red. Both did not play in real time, because it's a pretty heavy effect, but the 16-core was 42% more frames, which means basically you're going to have less stutter. Another new tool for Resolve is face refinement. If you haven't seen it work, it's pretty amazing. You can basically analyze the face, track it, and do all that stuff, and you can make fine-tuned adjustments from like removing bags under eyes, smoothing skin on the forehead, or maybe even changing the color of the cheeks, and it's all done and tracked and everything for you. So basically in this chart, lower is better and the 16-core is in red, while playback after using the tool was pretty much the same at 6 frames per second. The amount of time it took to analyze the footage was much faster at 58% for the new system. That's pretty huge. That difference in speed is enough to decide whether you're going to use this brand new tool or not. After watching the face refinement tool, you're going to want to watch it in real time. So here I cast just the node for that tool. Lower is better and red is the 16-core. And as you can see, the new system is 36% faster at caching out the footage, so you can review it. So how loud is this computer when you're sitting next to it editing? Go ahead and take a listen. So it's pretty quiet, and in terms if you compare this system to my old system, it's only 1 dB different, which is probably within the margin of error, so it's pretty close. All right, next up I want to talk about drives and how I have them configured. I've had them configured this way for probably the last 5 or 6 years, worked really well for me. I thought I'd revisit again for you because basically the configuration hasn't changed, but the type of drives that are in there have, so I thought you guys might find it interesting. Start with the C drive, which is located right here. It's the new M.2 MVMe drive, so Windows loads super fast. I've never had an MVMe drive before, so yeah, that's pretty cool. Going to my M drive, on the back is a 2 terabyte SSD. I call it M because it's media. It's where I store all my media. So it's basically all of my working projects, the one I'm working on right now. Now, originally when JJ set this up, he had the 1 terabyte MVMe drive for this because he was thinking, well, Dave needs the really fast on the media drive. Well, it comes out that I don't really shoot like 5K raw footage or Mini Ursa 4.6K raw footage and have like 4 or 5 different streams on a timeline. In that case, yeah, you probably would want that to be the NVMe drive because you're gonna be pulling data off that drive really fast. So what I've changed it to is the 2 terabyte SSD because the Sony cameras that I use, XAVC-S, Kodak, the streams that I put, even like I showed you, if I have 4 streams, it can play back just fine, you know, in real time, which is pretty amazing. And I hardly ever have 4K concurrent streams running on the same time. So I needed the 2 terabytes. So what happens for the M drive, the media drive, after I'm done with projects, they get moved to these 2 hard drives, N and O, because it's M, N, and O. So these 2 6 terabyte drives, I only really write to them. I never really read from them. If I read from them, that means I've done something by mistake and I've deleted something and I had to, you know, basically restore something. Moving on to S drive. S drive stands for Scratch. Both Resolve and Premiere Pro, you can set up Scratch drives. And this is where I use the 1 terabyte, which is located right about here, I think. The 1 terabyte MVMe M.2 drive. So super fast. So what happens here is like that face refinement tool that I showed you. Basically, after that's done and I can't play it back in real time, I want to cache that node out. And what happens is it's going to use the Scratch drive to create the ProRes, if you're using, I guess, Macintosh, or, you know, a DNX, HR, HD type of files. So you can play it back in real time after it's been cached. So I need both good read and write performance on that particular drive. So that works really well for me. And then the last one is X drive, and that's the 1 terabyte drive SSD that's on the back here. In terms of capacity, 1 terabyte works fine in terms of the exports that I do. But in terms of speed, I don't know if it's necessary even to have an SSD. I've run tests on this in the past for Premiere Pro and Resolve. And basically, if you look at what's coming off from those programs onto that X drive, it basically is not that much information being spewed at it quite quickly, because it takes the CPU and the GPU to chunk on that data, and then it throws it in chunks to the X drive. X stands for export. So that's pretty much it for the drive setup. All right, so it's conclusion time. First off, I want to say thank you very much. Having them out here is just fantastic. And I've been peppering them with questions. It's 7 o'clock on day number 2. And we're pretty much done with all the benchmarks. You've buttoned up the case. And we just kind of want to talk generically. And I want to also kind of address I think a lot of people are thinking, well, do I go Intel 16 core or do I go Threadripper 16 core? And JJ's got some really interesting thoughts on that, especially in terms of voltages, and I'll let him talk about that as well. But I think overall, you know, we're looking at some of these tests, and I am not like any sort of great benchmarker, because I have a lot of respect for people like Ryan over at PC and Paul at Paul's Hardware that do these type of benchmarks all the time. And I think when we look at the synthetics, is that benchmarks, yeah, the 16 core is totally crushing my 8 core. When you look at the numbers, like of your real bench numbers are way higher. Yeah. And maybe I'll put them right here, what those are. And then you've got other synthetics that we've done. It's totally crushing it. But when you look at something and Premiere Pro, it's doing better. It's definitely doing a lot better performance-wise. For the rendering, it's performing great. Drop frames was better. We just had that weird anomaly with the Ursa Mini 4.6K. Right.
But in all the other ones,
maybe I'll dive into that more and try to figure out what's going on. So definitely a lot of performance improvements on Premiere Pro. Resolve, again, is really heavy on the GPU, so we're not seeing as much, and that's the program I use. But yeah, it's definitely a beast of a computer.
For sure. Yeah.
In fact, I think in terms of naming the computer, because I've always had a name, and the reason I put the names up is a lot of times you'll actually see, like what I'll see is the search results. People actually search for Dave's Beast computer or Dave's Monster computer. So I think I'm going to call this one, and I'll have to I can't remember his name that came up with the idea. He said, I think it was HAL 2.0. So if you are a Stanley Kubrick fan, you'll understand that reference. But I'll call this one HAL 2.0, maybe even the title somewhere. So if you search for this video, you'll find it. And I apologize, this is a very long video, but there's a lot of great content. JJ is awesome in terms of coming out here, setting this up all for me. This has been fantastic. I've really enjoyed the last couple of days, so thank you very much.
Thanks for having me. I think, for me, it's always really interesting, not only just as a very basic content creator, to be able to meet somebody with you that has, of course, much more aptitude and does this day in and day out, but it's always really interesting to be able to see the narrative of how this modern modern generational hardware really applies to being able to benefit somebody. Like you said, we saw definitely multitude of scenarios where there was definitely big performance uplifts, and we saw some scenarios where there wasn't really that much. At the same time too, we had a fairly short amount of time. We've realistically only had, you know, total time about not even a whole total day in terms of 24 hours. And there's still maybe even some more room for some single thread overclocking, which might have benefited some of the Resolve numbers, because what we were seeing in Resolve was a lot of GPU dependency and a lot of single thread utilization. And so that's actually one of the strengths definitely of the Skylake X architecture. And, you know, going back to what you were talking about when we talk about Intel to AMD, you know, we see both sides of the fence, and both platforms right now are truly high-end enthusiast platforms that will give you great experiences. But there are still some key differences in terms of what platforms are capable of. And I think more importantly, how you can approach tuning them. One, when we talk about overclocking, the frequency range right now on a Skylake X CPU is going to be higher. So we are going to generally be able to reach frequencies of, you know, 4.2, 4.3, 4.4, 4.5 gigahertz, especially when we start to look at per core tuning. When we take a look at the Ryzen Threadripper platform, it's very strong in terms of all the CPUs allow for overclocking, but you're generally looking at a limit of about 4 gigahertz, possibly 4.1, but it can become challenging. There's definitely thermals to play in, right? We put this with a really nice high-end, you know, that fractal Celsius S36 helps to keep things cool and quiet. But it's a 360-degree rad, and you're dealing with a lot of cooling to be able to dissipate the level of performance that we're targeting. And voltage plays into a lot of this. And while a lot of you might not technically get all the nuts and bolts of how all this works, the Intel architecture allows for something that's called adaptive voltage, which is an exclusive technology that they have right now on that works with the motherboards and the CPU. And what that really means is that when you're doing minimal or moderate workloads,
like just browsing the web,
browsing the web, checking your photos, watching videos, even going into moderately lightly applications like, you know, maybe like Lightroom, which is notoriously only single threaded,
that voltage will,
the voltage is going to come down, or it's going to stay within a fixed level, and this helps to maintain lower power consumption, less heat. And when we go up into the higher, more aggressive overclocks, then the voltage will increase. Whereas if we look at overclocking to, let's say, like a 4 gigahertz on a comparable Ryzen Threadripper, it's usually using a static voltage.
So it's always high, like at 1.4?
Yeah, exactly. Like so, you know, exactly. If you were overclocking to 4 gigahertz and you had it at 1.4, it means it's always going to be at 1.4 volts consistently. So that is something that you have to factor. And then you also look, I think, at the totality of other areas on how you can improve performance. Here we're only using a 3200 kit of memory, and you could even, if you have applications that are taking advantage of DRAM bandwidth, we could go faster. You could go 3400, you could go 3600. On AMD right now, 3200 is probably about realistically the limit of what could sensibly be achieved in an ultra high density configuration. Definitely we've had on some of our enthusiast boards, we can get a little bit more, maybe 3400, maybe 3600, but it's not going to be in an 8 DIMM channel population. So that's another difference. You then throw in some other aspects, like you do maybe have some usage for Thunderbolt. Thunderbolt's not necessarily an option that is available. So you want to look at the entirety of the platform, how the platform can be tuned. You know, at the end of the day, I think both are going to be fantastic options for content creators. There's no arguing that for this, you know, ultra high bitrate era, 4K, 5K, you know, 6K era, multi-camera, all these different types of footage scenarios, that having these level of cores and counts are fantastic. But definitely here, there's a lot of performance. And I think also the last note might be upgrade path here. If we take a look at the X299 platform, we know the CPU is just about to come out, right? Or be coming out by the time maybe this video is released. It will be out, but you will fundamentally be able to buy an X299 motherboard.
And we don't know the prices of...
Correct.
We know the prices of your boards, but we don't know the prices of
the CPU, right? At this point, we don't know the finalized release price. But if we take a look at what somebody could consider about building a system, and definitely with these type of systems, we see you have a longer term lifespan in terms of what people buy into. You're going to be able to go all the way down to the entry level Kaby Lake X299 CPU, and you will be able to upgrade all the way up to an 18 core 36 thread part. That's an extensive range and a lot of flexibility that maybe if you're first starting off and you've got a lot of investment in 1080p camera equipment and you don't see yourself jumping into that 4K era for 2 years, maybe you don't need to jump into, you know, that higher end CPU bracket. But 2 years down the road, all you need to do is just drop in that next CPU and you'll be able to go into a whole nother level of performance. So really interesting, but overall, it's been awesome to be able to put together the system, and I look forward to your continued kind of real-time feedback and experience on what it looks like for you, you know, as you get to use it, you know.
And I still don't know. We'll find out if I get to keep this one, the 16, or I'll actually get a 10. If I get a 10, I'll create a separate video.
And we'll see what the performance markers
on those
will be.
benchmarks as well. So I think a lot of people are in the same situation. They maybe upgrade every 3 years when a new platform comes out. And I think this has been very helpful having JJ here answering all these questions that I had upgrading to this newer platform. Maybe a lot of people are going to be in a similar situation where, like, I would love to see a video that kind of covers all that stuff. And I think that's just kind of very comprehensive video that hopefully will end up being put together at some point in 10 days when this comes out. So that's pretty much it. And I want to just thank you guys for watching, and I'll talk to you guys later. Bye.